Okay, thank you. I'm sorry I can't be there in person today. It was just a little too far to fly from all the way from New York. But I want to start by thanking Kevin for giving you such a great intro, in a sense, to what architects do and the way architects think about this problem. Next slide. And really to start to sort of frame that by saying that what architects are doing every day is making millions of material choices and assembly choices in terms of what we build our buildings with and how we put those materials together. And this idea that these choices have massive consequences for ecosystem and human health is actually a relatively new and emerging idea. And this Better Building Materials publication, just in the process of being released by the U.S. Green Building Council, is the beginning of understanding that materials, the building blocks of architecture, do have, as I said, these massive consequences. Next. So I know that prior speakers have said we're spending 90% of our time indoors, but I think what's important is to understand the kind of the cumulative impacts of being the first generation to spend 90% of our time indoors with these indoor pollutant levels that are higher. I also love to show Opry in Nashville, because we now build indoor environments and think we're outdoors. So in these restaurants in the Opryland Hotel, they will actually ask you if you want to sit outside, but outside is still really inside. So increasingly, we're unable to almost tell the difference. Next. We're also continuing to tighten and tighten and tighten buildings. Like, we went through the first age of tightening buildings in the 1970s, and we learned about sick building syndrome and building-related illness, but we're continuing to tighten buildings in this quest for net zero energy performance. And so this just is, a headline from New York adopting passive house standards to further tighten and further increase the full reliance on mechanical ventilation for indoor environments. Next. If we kind of frame this across what has happened in architecture, in the 19th century, most simply, we lived in houses, sometimes actually, to go back to Rob Knight, with thatched roofs. We burned wood in a fireplace to heat it and cool it, and it was fairly porous buildings, not much insulation. We lived with the outdoor and indoor microbiomes being fairly mixed. By the 20th century, we developed all these fossil fuel-based systems to heat and cool buildings, moving away really from the idea of indoor fireplace heating, but where the buildings actually still had some porousness, where outdoor air still infiltrated through the building envelope, and we could open and shut the windows as the formal way of getting, quote, fresh air. But even if you left your windows closed all winter, there was enough infiltration through the envelope to not worry about it. We're now moving into the 21st century of passive house, where the notion is to super insulate the buildings, completely cut the infiltration, so that we no longer need the fossil fuel-based systems and allow sunlight to do some form of mediation and then mechanically ventilate. So this is an evolving process. Next. And actually, we have to contrast this, and I swear I didn't know Rob Knight was going to talk about putting pigs in the wall, but we have to contrast this with what our buildings are made of. That in 1900, in the house on the left in the prior photo, about 50% of the materials that building was made of was in some way from naturally renewable sources. 100 years later, only 6% of our building materials are natural renewable sources. So next. So what our building materials are now are petrochemically based materials, everything from insulation to coating, paints, adhesives, caulks, wall coverings, flooring, are often made from derivatives of oil, which in order to ensure that you can put them in buildings for a long life product, and they won't burn or ignite, are filled with a fair amount of chemical additives. And in order to achieve very different performance attributes across all these categories of building materials, the formulation of these products is highly diverse. Next. And so I guess my first question that I think architects really want to know is, how does total reliance on mechanical ventilation impact the interior microbiome? And really, as we move to these tighter buildings, what are we doing about the exchange? Next. This is actually a photograph of a PASSIVHAUS apartment complex. And this question about what's happening to sunlight, I know Jessica talks a lot about sunlight and its role in the microbiome in buildings, but increasingly we are moderating the amount of sunlight that comes into our buildings because we're trying to cut heat load from the building. And you can see in this little thumbnail on the left that we're using triple glazed, double low E glazing. We're putting high performance coatings on windows so that we actually are filtering which components of sunlight are entering the built environment, if we're allowing sunlight in at all, because as Kevin pointed out, a lot of the ventilation systems that we're looking at actually don't want hot spots on the floors. So we're doing more sophisticated facade or envelope design in order to keep direct sunlight from hitting the floors and interiors of our buildings. Next. And of course, you know, this is in the popular press. I mean, this photo of a Business Week cover was really from about 15 years ago. This notion that people are increasingly skeptical that the indoor environments that they're spending 90% of their time in are healthy, and that's both from the elements that the pollution that occupants themselves introduce, as well as the VOCs from the building materials that the plants may or may not be eating, if we go back to Michael's talk, but increasingly asking this question about the healthfulness of buildings and what's going on in the microbiome. And then next, the related one, of course, this is the one that everyone is scared of like crazy, the Wall Street Journal doing articles on taking samples from hotel air, transient population, and actually trying to analyze the microbiome of hotel environments. All it does is terrify everybody. And it raises more questions than it answers. Next. And if we go to hospitals, where I actually spend a fair amount of my time, one of the obsessions of the current healthcare system in the U.S. is to reduce the occurrence and the spread of hospital-acquired infections. And that desire to reduce infection rates in hospitals has spawned an incredible proliferation of synthetic building materials that have presumably enhanced antimicrobial properties. Next. And so that leads to our second real question, which is, what is the role of the interior microbiome in hospitals in hospital-acquired infections? And I think no one knows the answer to that, and so material manufacturers can in fact sell the idea of enhanced antimicrobial properties in building materials at premium prices to an audience of architects, designers, and hospital facility people, with the promise that it may in fact have a beneficial effect on hospital-acquired infections. So next. This is an example of one of those kinds of products. Paint Shield microbicidal interior latex paint, a relatively new entry in the building products market from Sherwin-Williams, a respected U.S. paint manufacturer. Paint that presumes to kill MRSA, et cetera, and, you know, based on applications on walls with an efficacy of about 4 years. And this is only one of many products that I could have shown that really is about adding antimicrobial compounds or biocidal compounds that go above and beyond concerns about mold and mildew, or above and beyond the antimicrobials that would be added to paint on a routine basis to preserve shelf life, which has been a kind of accepted use of antimicrobial additives in a number of building products for a number of years. But this is way above it. So next. So earlier this year, Healthcare Without Harm released this position paper or paper on the state of the evidence about antimicrobials in hospital furnishings. Do they reduce healthcare-associated infections? Because we're seeing these antimicrobial coatings showing up on textiles, not only in that bicidal paint, but based on the literature review and the review of the evidence, Healthcare Without Harm's findings were that many of these products have not actually had testing, and they're not recognized by FIFRA and by for being biocides or having antimicrobial properties. They're not able to talk about particularly which microbes they're targeting, which ones they're not. And so Healthcare Without Harm sort of joined some leading health systems in saying, we don't really know what impact beginning to target specific microbes in the built environment may be having on the microbiome as a whole, and therefore maybe it's not a good idea to selectively target. Next. So that gets to question 3. If we begin to introduce added antimicrobial building products in our indoor environments, what impact is that going to have on the interior microbiome? Will it produce more resistant microbiomes? Will it actually reduce the beneficial organisms and produce more resistant negative organisms? I think that's what leading healthcare institutions are concerned about and would love to know the answer to. Next. Because one of the issues that we need to remember is that products that are introduced, presumably to have a beneficial impact in healthcare built environments, are then cross-marketed to the broader built environment market, meaning what's good for a hospital clearly should be good for an office space or a home. So I believe that this using healthcare as a wedge market, these products are actually finding their way into more places. I also will go back to something that actually Kevin talked about, which is, in a sense, that the other problem that you're dealing with when you start talking about building products and the use of building products and chemical composition in architecture is that no one actually labels building products with their contents. So none of us actually know what is in most building products that we are specifying or installing in buildings. We may know if they have something like an antibacterial additive because someone's marketing because of that, but rank and file we don't know. And there is this incredible movement underway in the architecture and design industry to foster voluntary disclosure of chemical composition of building products, going all the way back to the petrochemical synthetic explosion of products and clearly not knowing what their composition is. Next. So you see that in Red List. The Health Product Declaration Collaborative is the first voluntary open source standard for declaring the ingredient list in building products. And it just released its version 2 and this companion user guide to begin to help architects understand and sift through the chemical composition of building products, including things like added antimicrobial treatments. Next. And I'm going to close on this subject of household dust because the 2016 study of household dust, next, which was done by George Washington University, Silent Spring, National Resources Defense Council, Harvard, and UCSF, really actually was an attempt to compile every published study since 2000 that has references to, that have studied the composition of household dust in America. And this is the kind of indoor dust chemical composition. And it actually, this idea leads me to actually the fourth and final question. But you can see that the dust is including flame retardant chemicals, plasticizers, stain and stick resistant chemicals, PFOAs and PFAs, fragrance chemicals, phenols, often used in adhesives and binders, and, as I said, phthalate plasticizers. So if this is in the household dust, next slide, what effect does the introduction of these synthetic chemicals and the VOCs have on the interior microbiome? And I think none of us really actually have a clue about that either. We certainly can begin to see the inhalation of those chemicals having health impacts, but not really understanding how the appearance of those chemicals in interior environments affect the broader microbiome. So next, I think that may be it. That may be what I wanted to end with. So thank you very much. And I guess we'll take questions.